So after we created a mesh, now we can run our simulation. We can run simulation by right-clicking here on the solid body and click run here. Or we can start simulation here, run this study, or we can go here to simulation and here we have run. So let's click here and let's start simulation. And our simulation is done. So now if you look here on the left side, on our tree, we have a folder results. And we have 3 chart plots: stress, displacement, and strain. And those are default. If you want to change those default charts, you can go to simulation, options, default options, and here you have static study results. Plot 1, here we have result component, von Mises stress. As you see here, von Mises. Then we have displacement plot 2 and strain plot 3. So you can click here and you can change what you want to see, what result you want to get. But in most cases, we want to see stress, displacement, and strain. So let's cancel this. And now we have active stress. Here we have a legend. Here we see yield strength and minimum stress and maximum stress. So we can go closer to our model and let's go to this side. So we see that we have the biggest stresses here, here on those holes, and here, as we predicted. Those one. Now, if we want to see where is the maximum stress, we can right click on the stress, chart options, and here we can go show minimum and show maximum, and OK. So we have minimum here, and we have maximum here, as we predicted. Now, if we want to see displacement, we can just double click here on displacement, and now we can see displacement in millimeters. So we have the biggest displacement here, and here we have displacement 0, because this plate is fixed. And if we want to see strain, we can just double click on the strain, and now we see the strain results. Sometimes displacement, it seems like it's accurate, and the stress, it seems like it's not accurate. It's not something you expected. And this is because software first calculate displacement, and then based on the displacement calculate strain, and then based on the strain calculate stress. So here is the chain. One depends on the other. And so mistake can transfer from one to another. So in that case, if you see that you have displacement, something that you expected, and you don't have stresses, something you expected, then you can go with finer mesh and run study again. Now we want to create a new chart, and this is factor of safety. So what is factor of safety? So factor of safety assesses the safety of the design based on the maximal stresses, the material properties, and the failure criteria. So for each point, the factor of safety is calculated as a ratio between yield strength and stress in that point. And the yield strength is the strength where material starts to behave plastically. So we can right click on the results, and here we have define factor of safety plot. Let's click here. Let's click OK. And now we have a new chart, factor of safety. And here we have a legend. So we see that we have minimum factor of safety 2.26, and here we have a maximum. So we want to get that the minimum factor of safety in our model will be at least 3. So in this case, for us, this model is too weak. It can break maybe. So let's go right click on the factor of safety, chart points, and let's show minimum factor of safety, and we have the minimum factor of safety here. So after viewing the results, stress, displacement, strain, and factor of safety, we can conclude that we have to put some material, that we have to add some material to our model to increase the minimum factor of safety to at least 3.